Read this sentence. Tim Cook announced that Apple will open a store in Paris in March. You instantly know Tim Cook is a person, Apple is a company, Paris is a place, and March is a date. A raw keyword search sees none of that. It just sees a bag of words. Named entity recognition is the task that teaches a machine to pull those real-world things out of plain text. Here's how it works. Let's start with why plain search falls short, because that contrast is really the whole point of the task. Keyword search matches strings, not meaning. Type the word Washington and it happily returns a person, a state, and a city all mixed together because it has no idea which one you meant. It finds words. It never understands what those words refer to in the real world, so it can't tell George Washington the man apart from Washington the state. NER goes further. It locates spans of text that name real things and labels each one with a type, like person, organization, location, or date. Instead of a flat string of characters, you get structured, typed entities that a downstream system can actually reason about, store in a database, or link into a bigger web of facts. To see how it actually pulls entities out, follow one sentence as it moves through the pipeline, stage by stage. Everything begins with the raw sentence flowing in as plain text. At this stage, the machine has no notion of names or types. It's just a stream of tokens, and the whole job is to find the meaningful pieces buried inside it and figure out what each one actually stands for. Next comes detection, and this is trickier than it sounds. The system has to find the boundaries of each entity span, and a single entity can be several words long. Tim Cook is one person, not two, so the model has to decide exactly where each name starts and ends. Then each detected span gets classified into a type, and context does the heavy lifting. This is where ambiguity bites. Apple could be a company or a fruit, and Washington could be a person, a state, or a city, so the model leans on the surrounding words to decide which meaning fits before it commits to a label. Finally, out comes a clean set of typed entities. Tim Cook tagged as a person, Apple as an organization, Paris as a location, March as a date. That messy sentence has become structured facts a program can store, search, and connect. Now, three ideas really carry this whole task, and they build on each other. First, NER is really two jobs stitched together. Detection finds where an entity span begins and ends, and a span can run several words, like a full company name. Classification then assigns its type. Get either one wrong and the fact you extracted is broken, so both halves have to work together. Second, context resolves ambiguity, and it's the hardest part. Approaches evolved from handwritten rules and name lists to sequence models like hidden Markov models and conditional random fields over word features, to today's fine-tuned transformers like BERT that read the whole surrounding sentence to disambiguate a tricky name. Third, this turns unstructured text into structured facts. That's why NER sits underneath search, question answering, chatbots, and resume parsing, and it's the engine that builds knowledge graphs, extracting entities and the relationships between them so a machine can finally reason over what a document actually says. Alright, for takeaways worth holding on to. Named entity recognition finds spans of text that name real-world things and classifies them into types like person, organization, location, and date. It splits into two subjobs, detecting the boundaries of a possibly multi-word span, then assigning that span a type. Ambiguity makes it hard, so modern systems lean on surrounding context, moving from rules to sequence models to transformers like BERT. By turning messy text into structured facts, NER powers search, question answering, chatbots, and knowledge graphs across the whole field. If you enjoy AI concepts explained this clearly, Standarity.com has plenty more waiting for you.